Okay, ladies, so this is question 8 in your worksheet. We haven't solved this question. Well, basically it says that 1.144 grams of aluminum compound X reacts with excess water to produce a gas. The gas burns completely in O2 and forms H2O and 72 centimeter cube of the CO2 only. The volume of CO2 is measured at room temperature and pressure. What could be the formula of X? So here's the idea. We know something, that we have CO2, and this CO2 is being produced by H2O reacting with something, okay? Let's just put a red box here, okay? And this red box, whatever is in this red box, is due to aluminum, where there's a compound here, okay? And this is not aluminum alone, because we know it's aluminum compound, okay? And the aluminum compound is reacting with H2O in excess and producing a gas, okay? And in the process, not only is it producing a gas, it's producing aluminum and probably with oxygen, right? And the gas would probably be something that has hydrogen in it. In this case, the most possible candidate is X, because we have C here and C here. And remember, this is the one that we are going to put in our red box. Okay, let me just wipe down my mess. Okay, so let's write that again. We have aluminum, and it's a compound, so we have something next to the aluminum. And it's reacting with H2O and producing a gas. And in this case, it's CXHY, and this gas is, and this is a gas. And they are also producing something with aluminum, okay? Just let me fix this. They are also producing something with aluminum, probably aluminum oxide, okay? So this we're not going to look at for now, because we don't care about this. What we do care about is this lovely angel here. So we have CXHY that is being burned with oxygen and producing CO2, okay? And it only forms CO2. Okay, maybe it's forming H2O, maybe, but in gas form it's only producing CO2. So we have gas form here, and it's going to produce H2O in liquid form. Okay, so here's what we know. So I'm gonna wipe this down. I'm gonna wipe this part down just a second, just to write what we know about this reaction. Okay, we know that we have H2O liquid because it's a liquid, because it's the reaction that has gone to completion, and it's a combustion reaction. We know that we have carbon here because we have carbon here. We know that we have hydrogen here from the water. Okay, so this is hydrogen from the water. What we also know is that we have 72 centimeter cube of gas being produced here. And the interesting thing about gases, again, is that we can figure out how many moles of gas is reacting by just using their volumes, because any mole of gas at room temperature is equal to 24 decimeter cubed, right? So 1 mole, I'm just going to write that down, is equal to 24 decimeter cube. I could get CO2 moles produced just by using our 72 centimeter cube. And how am I going to turn this into decimeter cube? I just go over 1,000. So if I just want to, let me just divide this by 1,000 and fix my, okay, and fix this because it doesn't look like a cube. Okay, so we fix this, and then we do a cross multiplication. And when we do a cross multiplication, N of CO2, and N is always used to express moles, okay? So a small n is always used to express moles, is 0.003 mole, okay? You can check that on your notebook, okay? But for now, we only got the number of moles of CO2. So now we have the number of moles of this. So instead of writing 72 centimeter cube, I'm going to wipe this down. And I'm going to write moles instead. So we have 0.003 moles, right? Right. But this is not a correct or an integer. So I cannot go in here and say that this would be 0.003, right? Okay. So what can I do? Okay, I'm just going to move this up like this and talk here for a second. So what we have here is that we have 0.003. Remember that we have another equation that is AL, and AL has C in it, okay? And that's what we are being asked about. And if you are in doubt, check the multiple choice questions. They are, so we have ALXY again. Okay, no, not to be confused with the other one. We have ALA, let's call them A and B. Okay. And this is reacting with H2O, and they are producing this compound, the CXHY, and some other compound that contains Al and oxygen, okay? Now the idea is that we know this has 0.144 grams, right? We know that this is in excess, okay? What we do know is for sure we have 0.03 moles of CO2. So how are we going to connect this to the information that we have? Okay, good question. Take a moment, think about it. So the moles of CO2 are this. We have 0.003 mole CO2. And if we only look at the carbon, the moles of carbon would be, just the carbon in the CO2, they would be 0.003 moles. Because we have one carbon for 1 mole of CO2. So if we want to actually do this as a cross multiplication, we can say that 1 carbon exists for 1 CO2, right? For 1 mole of CO2, we have 1 carbon, this one, right? If we have okay, let me just write it on the right side. If we have 0.003 moles of CO2, how many moles of carbon do we have? And if we cross multiply, the answer would be 0.003 moles of carbon. Yay! Okay, so we got the moles of carbon. How is that going to help us or get us anywhere? Okay, so let me just wipe this down. So we have moles of carbon now. Well, we can't do anything with this in the first equation. Or in the second. So let me write the second equation, that one that we already have. So that would be CYHX or CXHY plus O2. That would go to CO2 and H2O. We can't do anything with the 0.003 moles, right? There's nothing we can do. We don't know the amount of oxygen. We don't know how much liquid do we have. We don't know even this. But we do have one other thing. So if we put ALX, okay, which is aluminum, and we have carbon, aluminum carbide, and we have them reacting with H2O, and they are going to CXHY, and they are also producing some form of aluminum oxide that we don't care about. It's not that we cross it out, we just don't care about it at the moment. What we do know about this second reaction is the following. 0.144 grams of this compound are reacting. So why should I care? Well, because the carbons here are the same one being produced here and are the same one being put out in CO2. So, if I could find the mass of carbon, I could magically find the mass of La. So let's get the mass of 0.003 moles of carbon. So how do we do 0.003 moles of carbon? So we want mass of C, right, of carbon. And that would be 0.036 grams, okay? Because we have the molar mass, which is 12 grams per mole, and we have the moles. Okay, so 12 by 0.003 would be 0.0036 grams. Okay, now we got the mass of carbon. What does that have to do with anything? Well, we have the mass of carbon. I'm just going to wipe that down. So, we have this. 0.144 is equal to mass of Al, which is aluminum, plus mass of carbon, right? So we have the mass of carbon, which we got, so we need the mass of aluminum. And in this case, I'm going to wipe this down now because we don't need it. Okay. In this case, our mass of Al is equal to 0.144 minus 0.036, which would mean we have 0.108 grams. Okay, great. So now we have our grams. We have our mass of Al. What we need is to actually figure out the ratio of Al to carbon. So, just to recap, we have 0.003 moles of C, and we want to see how many moles do we have here, how many moles of Al. And in this case, moles of aluminum are equal to 0.004. You can get the aluminum. Now take a minute to figure out how we jumped from grams to mole. Okay? Okay, so I just wiped down the previous ones. So we have 0.003 moles of carbon and 0.004 moles of Al entering the reaction. Now the ratio between them are the same. If I multiply this by 1,000 just to get an integer, and I multiply this by 1,000 just to get an integer, I would have Al for C3. And that would be my final answer. So the only reason we got the integers was because these are parts of the same equation. We didn't divide them by each other because they are parts of the same formula. Okay? They are not part of something that is different. They are part of the same formula. Okay? That's why we did not divide them by each other. Okay? That's all. And even if we did divide them by each other, we should end up with something very similar to Al4C3. Okay, so thank you very much. I hope you understood the idea behind this question.